take a look here. I'm going to try to, let's try to explain what that concept of limit is, right? We all should know this function here. You all recognize it? I'm blocking it there. You recognize it? So I'm blocking the screen. Right. This function here is what? X, right? F of x is x squared, right? Okay. So you want to understand the concept of limits, right? So a limit is written like this. Limit of a particular function. You'll see there, right? The limit of a particular function as x approaches some value is equal to, well, L. Right? So we are going to look at a function f of x, and we're going to see as x approaches a value a, what that function f of x approaches. All right? Let's see if that makes any sense, right? So here we have the function f of x is equal to x squared. All right? Let's pick a value. Let's pick 3. Right? So here's what we would like to see. We would like to see the limit as x approaches 3 of x squared. Right? Here's how you work out that limit. So 3 is here, right? This entire vertical line is 3. This entire vertical line here is 3. Right. So when I say as the function approaches 3, here's what I mean. If I were to take the function and starting here and approaching 3 from the right-hand side, what y value am I approaching? You're seeing as 9? Watch again, right? So I'm starting here, I'm starting on the right-hand side of the curve, and I'm approaching that value 3. Right? When I reach at 3, I am approaching this y value here, which is 9. You're seeing that? Yeah? If I were to approach from the left and I approach 3, what's the y value I'm approaching? Same thing, right? 9? You're seeing that? So the value I'm approaching is 9, right? So what that simply means is that the limit of x squared as x approaches 3 is 9. Right? Watch it here again. Let me take off this graph here. So if I were to approach the function, right? When I reach 3, I could come across here and check and see what y value it is. That y value is 9. If I were to approach the function from the left-hand side, I reach in the same y value, which is 9. So what that means is that the limit of x squared as x approaches 3 is 9. That's what I mean by limit. What value or what y value, right, will the function be when x approaches 3? Are you okay with that? Are you okay with that? So suppose I gave you a graph looking like this. Suppose I gave you a graph looking like this. This function will approach what value? Let's say x going all the way down to the largest value. This function f of x, what value will it approach? It will hopefully touch the x-axis, right? So if it touches the x-axis, y is what? 0. That's okay? 0, right? It will approach the x, it will come real close to the x-axis. So it means it approaches 0. That makes sense? Where? I'll go again. I feel it makes sense out there. I feel it makes sense out there. Let's do our next function. Let's do the function. Let's do the function y is equal to x. Right? I would like to know the limit as x approaches 4 of f of x, right? In this case, f of x is x, right? So my value here is 4. My value there is 4. So let's approach 4 from the right. What will the answer be? Anybody tell me? Anybody could make a guess? Right. All you're doing is putting the x value there, right? That's 4. Correct? So it will approach 4. All okay with that? Yeah? You understand the concept? Okay now? Yeah, I'll do the next one. But if you look at this one here, if I approach the right now, sorry, if I approach on the left-hand side, what will I get? Same answer. So what I want you all to recognize is for a limit to exist, it has to be the same value when you approach from the right and when you approach from the left. Right? I want to show you an example where that does not happen. Watch this here. Let's say I gave you this function. Forget what it really is, right? Let's say I gave you a function looking like this. Right? That function f of x. It's called a piecewise function. I'll explain that in a little while. But let's say I gave you a function like that. Right. Let's see if we can find the limit of f of x as x approaches 3. We have a slight problem here. When you approach 3 from the right, right is here, right? So you're approaching 3 from the right, so you're coming down here. What is the y value? What's the y value? 6. So the limit, and here's how you write it. The limit as x approaches 3 from the right is 6. Are you okay with that? Let's approach on the left now. Left is a negative sign, right? Left is a negative sign, right? When you approach from the left, what's the y value we're approaching? 4. Saying that, when you reach at 3, just go across and read the y value. So the answer is what? 4. As well? You okay with that? But we have a slight problem here. The values are not the same. Right? When the values are not the same, what we say is that the limit doesn't exist. Right? But if those values were the same, then you could say the limit exists. Okay, concept of limit. That's the reason why we have to do it from the right and from the left-hand side. All okay online there? Rika, you okay with that? Savia? All right, so let's go to the notes, right? Right. So here we have the function. Actually, let's do one more. I want to make sure you'll catch it, right? I would like you to tell me what is the limit as x approaches 0 of this function x squared. What you got, good? And make sure Rebecca can see it. Check from the left and the right and make sure it's the same thing. Huh? If it's not the same thing, all you have to say the limit does not exist. And what's your thing? You do online method. Right, what we have here, see some good, look at answers. Hope all can stay like this in unit 2, huh? Yeah. What do you think, Israel? Your face looking like you're in between. 0, correct, right? When you approach from the right and you approach from the left, you're approaching the same value, which is 0, right? That's a concept of limits, right? The problem is sometimes you can't get a graph. So if you don't have a graph, here what you could do. What you could do is you could do this. The limit as x approaches 0, write the function, right? And instead of trying to catch it, here's what you could do. You could just plug in 0. right? Sometimes that's simple. Let's plug in the x value. That's okay. But there are times I'll show you later one that is not that simple. Okay. Right. So watch here. Here we have a function. For a function, y is equal to f of x as x approaches some some number a, f of x approaches some limit L, and it's written like this. That's okay? That's what we're talking about all the time. Are you okay with that? Right, for example, in the graph above, as x approaches 2, the answer is 4. Right? And we have to check it from both sides. As it approaches 2 from the left, notice I have a negative sign here. The answer is plus 4. Right? As it approaches 2 from the right, there's a little mistake. Remember to add that from right, I make a little mistake there. Right? As it approaches 2 from the right, the value is x plus 2, and the answer is also plus 4. So what that means is this. It's the most important thing for limits, right? For a limit to exist at a point, you have to get the same value as L approaches the function from the right and the left. So this here has to be true, otherwise the limit does not exist, right? Okay. So make a note of this, please. Right? For a limit to exist, the limit as x approaches a from the right has to be equal to the limit as x approaches a from the left. Right, that's very important. Please remember the positive sign is to the right, from the right, negative sign is from the left. Repeat the explanation. Right, so for the limit to exist, basically, what you have to do is check the value from the right and the value from the left, and they have to be equal. All right, I'm going to show you some examples now, right? All right, so let's try back. Let's go back to the last one. I have an error here. Next one then. That should be equal to, right? I don't have this original again. That's a problem. I can't fix it. Right, but that's supposed to be equal, right? All right, let's go back here. Use this same function formula and check and see if the function exists. It approaches 0. Oh, I gave it that already, right? Yeah. Okay. So as it approaches 0 from the left, f of x approaches 0. As it approaches 0 from the right, f of x approaches 0. Because they are the same, the answer is 0. Are you okay with that? So because this and this is the same, the limit exists. Josiah, you okay with that? All right, so let's take a look at our first piecewise function. This here is a piecewise function. Here's what they did. They split the function into pieces. When it's equal to 0, the function is 1. When it's less than 0, the function is 0. When it's more than 0, the function is x squared. So they split the function into 3 parts, and we have to be able to draw that. All right, so that's write that down, and I'm going to show you how to draw it. If you can join, go right ahead. If you can't, you can wait 2 minutes on me. Copy that down, I'll be good and join up together. If you can join, go right ahead. Actually, very want to try, so try it first. That's all I give point of view. Yeah. Last one, it's still entirely full.
Yeah, that's right.
Going on, you know. I'll take a little bit because you haven't go over.
Many books now about that.
Or you have to go over point test.
For that. Maths, I know maths. So they go over. Like. Think about 10.
Oh no, we have a little while again on your leave, right?
I love my English book.
Go wait. Right, give it a little try there. Very ready? Anybody remember how to draw an equal to? Like if something equal to on a number line. Like on a number line here. How is represent like if you have more than an equal to less than. Right. Follow the circle, right? Just keep that in mind because we need that step now. Right, try it now. I'll give it parallel time. Try that there. Just give it a little time. Pencil here, I will go. All right, so let's start. Let's start with when it's equal to 0. Right? When it's equal to 0, the answer is 1. Right? So I'm coming up here now, let's draw 1. Right? That value there is 1, right? When x is 0, y is 1. Are you okay with that? Yeah? Are you okay with that? When x is 0, y is 1. Let's do here now. When x is less than 0, the function is 0. So I'll draw what? A horizontal line here. Yeah? Right. We have a slight problem. This function, I have a slight problem, right? This function here is not defined when x is 0. So I have to put a hollow circle here. You'll see that? Not hollow, right? You'll see that? So because it's not defined, I cannot put a solid circle there. I have to put a hollow circle. Same thing here. Right? Same thing here. How will x squared look more than 0? X squared looks like this, right? But I do want here, and so how will it look? It will look like, it'll look like that. Yeah? So what you have in front of you is a piecewise function. Less than 0 is 0. Equal to 0 is 1. More than 0 is that little curve there. Any questions earlier? We have plenty to draw. Remember, I gave you a little tree. I gave you a few functions in unit 1 that you should know. X squared, 1 on x. Yeah, make sure you go over that list, right? I'll try and keep it to straight lines and I'll curve, right? So that's an example of a piecewise function in front of you there, right? Let's see if we can do the part on limits now. Any questions online on the function? something that's very important is that this part has to be hollow, right? That part has to be hollow because it's not defined. It's not it's not equal to 0 here and not equal to 0 here. All right, let's go to the next part. The next part looks like this. Does the limit exist? Does the limit exist at x is equal to 0? Work it out, tell me what you think. Does the limit exist at x is equal to 0? I can see. Tell me what you all think. If the limit exists, tell me what's the value.
I'm waiting for him. I know I put out that, but
I saw you there. What y'all think? All right, so let's see what you all have here online. No, yes, no, no, yes. All right, so let's see. First thing first, as it approached from the right, watch it good, eh? As it approached from the right, what's the value it approaching when it reaches 0? 0. As it approached from the left, the value is what? It approaching 0, nothing wrong with that, right? This is a problem. This is a problem, but we'll see it later on, what that problem is. So the answer is yes, it exists. And the value is? And the value is 0. So let's stay right here. Let's stay on this function. And I want to show you something here. There is something called, right? There is something called continuity, right? So for example, this, hello, okay with us? Hello, okay with this explanation for it being, for it existing, the answer being yes, online? Hello, okay with that? Shavish, Shabani, Rika, Paul, you okay with that? Brittany? Brittany, you ever send me any answer? Yeah, no, the hollow means something else. I'll explain that shortly. But in terms of the limit, as you approach the right and the left, it's the same value. So that's why the limit exists. All right, Emily? As you approach from the right and the left, you get the same value. Hollow or not, it doesn't matter. It approaches 0. So as you approach 0 from the right, it still approaches 0. As you approach 0 from the left, it still approaches 0. All right, so problem here is this. There is something called continuity. So for example, watch this here. This curve is continuous. Correct? Right? But what about this curve here? Is it continuous? No, have a little missing piece there, right? So we are going to learn about continuity and discontinuity. All right? So for continuity to exist, right, I want to go on board, right? I have one more mark. Right. For continuity to exist, 3 things have to happen. Number 1, right? Number 1, actually, let's turn here. Watch here, right? I'm coming back to this, huh? Right. These are the 3 rules. For a function to be continuous at a point x is equal to a, f of a must be defined, right? So, for example, f of 0 must be some number, right? If the number is k or 5 or whatever, it doesn't matter. It has to be some value. Then the limit must exist. So when you approach from the right and the left, you must get the same value. And those 2 things have to be equal. Once these 3 rules are upheld, it means that the function is continuous. Are you okay with that? let's go back to the last one. Watch this here. Does the limit exist? In fact, let's go in order. Number one, let us see if it's continuous at x is 0. What is f of 0? When f is 0, the function is what? 1, right? Remember that? Yeah? Look at here. All right. See now there? When x is 0, y is 1. Oh, remember that? Israel, you sure? You okay with that? So question number, the first part, f of 0 is 1. Number 2, we saw the limit exists and we saw that the limit is 0. Correct? So it was defined and the value is 1, and f of x when x approaches 0 is 0. Are they equal? Are they equal? Is the limit equal to f of 0? No. Watch here. Here is 0 and here is, sorry, here is 1 and here is 0. So therefore f of 0 is not equal to the limit as x approaches 0. No? So therefore, it is discontinuous. Therefore, it's discontinuous. So if you look here, the graph went down here, and when it reaches here, there's a missing piece, and it went across here. So a function like that is discontinuous. Right? So you're looking confused. Yeah? No? Fair? All right, so to show that something is continuous, we have to show 3 things. We have to show f of a is defined. We have to show that the limit exists, and we have to show that f of a is equal to the limit. If any of those is broken, it is discontinuous. Right? All 3 has to be upheld. That's okay? So let's go back to the example I made you through there. All right, let's go back to the example. So let's determine f continuous. Determine f continuous at x is equal to 0. So step number 1, we found f of 0. F of 0 is 1. Second step, we found the limit as x approaches 0 of f of x as 0. Step number 3 now, f of 0 is not equal to the limit as x approaches 0 of f of x. Therefore, it is discontinuous. All right, copy them. Let's go again. I've done plenty more like this. Copy them. But that's our real time. Alright, copy down, let's go again. I want you to tell me if this continues, right? Right, these functions are called piecewise functions that are split up, right? So it's not like me telling you plot f of x is equal to x squared. You have different functions at different points. Ready? Right, Ansel? Right, so as I told you, module 1 is limits, then differentiation and integration. 75% you know already. I'm just walking in here like you on the show. Walking up on. Ready? Let's go again. So I want to try on us. I want to try on a. Am I writing? Right. I want to try out here, right? So I've given you a function f of x, and we're gonna split it up here, right? Let's split up the function. When x is I carry on this side, right? When x is 2, y is about 4. When x is less than 2 and when x is more than 2. I want to give all the sum now, like a plot, right? Plot that for me. Plot that graph for me. Determine if continuous at x is equal to 2. Ready to draw it up, right? I try to give it the easiest thing I could get to draw, right? I'm really hoping for the best. Pass around and watch what the texture is looking like. Right, it's slow. I don't know why it's going. It's why that's so it has 3 parts, right? Start at 2, right? Start at 2. There's sketch, the little shaded. You don't always have to sketch, right? If you first start by getting it, it's sketch. Afterwards, I'll show you what to do with this what to do with it, do what color. And let's see if we can draw it out. Right? Those who are online, you could, well, I wouldn't be able to see a sketch, but you could tell me yes or no. If it's continuous or not. Oh, shucks. That's the loss. Let's not give up that line. Right, those who are online, you all can message yes or no, right? Yes meaning continuous, no meaning discontinuous. Ready? Let's just see what your sketch look like, right? When x is 2 is 4, so 4 is about here. When x is more than 2 is 7, 4, 5, 6, 7, so it's a horizontal line. Follow here, horizontal line, right? That's 7, that's 4, and 3 right there, right? Then you have a horizontal line all the way there. That is hollow, eh? Just a pen given some. Are you okay with the graph? Right, so while it'll help, I'm pick on somebody. Sean, number 1. F of 2 is what? Right, good. When x is 2 is 4, nice. Next, when you approach when you approach 2 from the right, and then when you approach 2 from the left, what you'll get? I'm gonna pick on next to Fair. What's the name again? Jason. Help me out now. When you approach 2 from the right, what you'll get? Very good. When you approach 2 from the left, 3. Very good. What you can say about the limits? Fair. No, what you can say about the limit? The limit as x approaches to f of x does, right, so it does not exist. So the limit does not exist. Therefore, now you could say, therefore, f of x is discontinuous at x is equal to 2. That's okay? So you had to state that the limit do exist first, right? Any questions online there earlier? How did you get 7? Oh, the question gave you 7, Josiah. This here is a 7. It looked like more than, sorry. See Nadia? Josiah? Right? Sorry, it looked like a more than sign, right? Wait. Any time already? Have we now start? Or come late? I'll meet them. Anyway, we're going to have a nice little piece. We'll finish anytime. Okay, so the limit does not exist. Everybody okay with that? So I'm gonna make it a little harder now, right? I'm gonna give you a slightly harder function to sketch. Question. Everybody can sketch x squared, right? Could you sketch x squared plus 1? What you'll do? X squared plus 1, you carry it up or down? Up 1. That's okay? So x squared minus 1, you'll carry it 1 down, right? If you had to sketch x plus 2, that's a curve or a line? A line. And what's its special feature? X plus 2 means you're carrying the line y equal to here. So x plus 2 means that the gradient is positive, and it means that the y-intercept is 2. Very good. Right? Bear that in mind, right? Are you okay with that? I'm going to give you one a little harder to sketch now. Try that, please. It's a little bit harder to sketch. Between -1 and 2, be careful. Without even sketching it, anybody could tell me if it's continuous at x is -1? What's your function? Good. Let me see if anybody catch on already. Look at the function. Is it continuous without even sketching it and working it out? Do you think it's continuous at x is equal to -1? I think. Shivani say no. No? Why, Andy? Andy, you're not sure. You're trying to shake a both yes or no? You're trying to shake a both yes or no? What do you think?
I think it is continuous.
Right? Think about it. Look at the graph. Look at the range here. Look at these values. Is it defined when x is 1? -1? Is it defined? No. -1 not defined here, -1 not defined here. So therefore, f of -1 is not defined. So without drawing it, you all can see this one. See now there? Fanny is Fanny. Venetia is seeing that? -1 is nowhere in there. Right? Shabara? Kilan? See that, right? -1 is not defined anywhere there. So therefore, you're sure it will be discontinuous. All right, go ahead. Try and draw that there, and then we'll take a look at how to work it out well, formally. But you know the answer already. But I really want to see it draw this. I split it up between my mouth. I'm not going to put it down. Yeah, no. Right, let me check all these sketches. Very good. Right, some of you all have it, but you forget to rub off some parts, right? So watch this here. X squared minus 1, 5 minus x. So let's go. Let's see if we could do this. What is again? Minus 1, 2. Right. So all the values less than minus 1 is what? 0? All the values less than minus 1 is 0. So here's hollow. And the reason I put in the hollow there is because I want to remind myself that that minus 1 is not included. Are you okay with that? Then x squared minus 1 means to shift the whole graph down 1, right? So x squared is here. X squared minus 1 is here. They shift the entire graph down. Right? But here's what I need to be. I need to make sure that, that I have the exact graph, right? So here's what I'm going to do. First thing I'm going to do is x squared minus 1, right? I'm going to put x is minus 1 here. Minus 1 squared minus 1 will give me 0. So I know I'm starting here. Right? So for this graph, my first point is minus 1, 0. Now I'm going to check when x is 2. So I'm going to put 2 now. I'm going to put x is 2. 2 squared minus 1 is 4 minus 1 is 3. So I'm going to unplug 2, 3. That's like somewhere here. So my graph will look like this. Are you okay with that? Fair? So it's going higher up, right? So you see how I figured out when x is 2 what y is? Yeah. So because you see, I know that x squared minus 1 looks like this. But there are parts I do not want. I don't want it less than minus 1, and I don't want it more than 2. Right? So here's minus 1, here's 2. Are you okay with that? So that's the first 2 parts. Kivara? Ramsing, you okay with that? Kyle is the first name, right? Right, now for you, I want you to figure out the last part. X is more than 2, 5 minus x. Is it a straight line or curve? 5 minus x is a what? Straight line, right? So when x is more than 2, 5 minus x is a straight line, right? So let's plug in x is 2. When x is 2, we'll get 5 minus 2, which is 3. So my first point is 2, 3. Is it defined there? Is it defined when x is more than 2? Yes. So when x is 2, y is 3, solid. Right? Minus x plus 5 means what? Positive gradient to negative gradient. Negative gradient. So will my line go up here or come down? Or go down? Done. That's it. That's hard. Israel? because they asked me to draw 5 minus x, which is the same as minus x plus 5. So it means that the gradient is -1. Mx plus c. If you don't like that method, here's what you can do. If you don't like that, here's what you can do. To draw a line, we need 2 points. We already know x is 2, y is 3. So we could pick x is 3 and solve for y. You'll get 5 minus 3 is 2. So when x is 3, you'll get 2 somewhere down there. 3 2s around there. That's 3, 2. And then plot your line. That's okay? Anyone you want. I just recognize a negative gradient, so I drew the line downwards. You're okay with the graph there? Karina, you okay with the graph? Amisha? You okay with the graph? So you kind of join them individually and you're cutting it off based on the domain, right? Right, today I'm doing the graphical method. The next time I will do it without having to sketch it, right? I know some of you all do like to sketch. So there's a next way to do it without sketching. Right now, answer the questions. Is it continuous at x is -1 and x is 2? Is it continuous at x is -1 and x is 2? Those who are online, just message yes, no, or no, yes, or whatever. Anybody online have questions on the graph? You can take a picture and send me yours. If you want to check it, you can send on WhatsApp. Right, Keelan sent his already. Ready, go? Check out the continuous. Check out the continuous x is -1 and x. Did the first one already, right? Check and see if it continuous and x is -1. That goes through all the steps, huh? Well, both are empty. Thank you. I online just message yes, no, right? Or no, yes, or yes, yes, or no, no. Time is well fly by. Which Shabani send me the wrong, yes, send me the notes up. Oh, okay. I'll check it for you. Ready? Any more answers? Send some answers there. Harris, send some answers. Adam. Both Adams. Right, so I am doing over x is -1, right? And in one line we finish, right? F of -1, is it defined? F of -1 does not exist. Therefore, discontinuous at x is equal to -1. So the first answer is no. Now x is 2. So a little mistake there, Anna. Wait, it wasn't Anna. All right, Shavish, good. Somebody submitted a mistake just now. Oh, we can delete it. All right, Adamson already. X is 2. What y'all getting? Jude? What you get? Yes or no? Andy, which one? Time up already. Anyway, I do the graphical. There you go. Nothing? Trouble? Trouble? Yeah, all right, help more then. Right, so let's start Israel. F of 2. When x is 2, what you got for y? How much? 3, very good. Let's check out the limits now. Approach the limit from the right. Tell me what you got. And approach the limit from the left. Tell me what you got. As you approach from the right and the left, tell me what you get. As we approach 2, right? So as you approach 2 from the right, how much you got? 3, very good. As you approach from the left, what you got? 3 again. What does that mean? So the limit as x approaches 2, it exists, and the answer is 3. What you can say about the answer in part 1 and the answer in part 2? Are they equal? Is f of 2 equal to the limit? So therefore, all 3 rules satisfied. So therefore, it's continuous. You okay with that? That's it, right? This is the graphical way, right? We'll look at the next way as well, right? So sometimes you do have to draw it. Without drawing it, right? How you will know which function to use if you're approaching from the right? Without drawing it. So you see here, we could just follow the line, right? From the right, and we could follow the line from the left. Suppose it's kind of hard and we can't draw it. What you will do? How you will know which function? It's a piecewise function again. How you will know which function to choose if you're coming from the right or if you're coming from the left? Everything on the right side, everything on the right hand side there is what? X is what? More than 2. And everything on the left side here, x is less than 2. So whenever you're approaching from the right, you look for the more than. Whenever you're approaching from the left, you look for the less than. So that way you don't have to draw it. And you just plug in 2. Watch it here and see. Anybody writing? You writing, sir? So watch this here. If I wanted to figure out as you approach from the right, I use any more than, and I'm going to unplug 2 in there. 5 minus 2 is 3. Less than is this function. So I'm going to unplug 2 in there. 2 squared minus 1 is 3. So as you approach from the right, 3. As you approach from the left, 3. Limit exists. Right? Check and see if f of 2 defined. Yes. F of 2 defined. Plug 2 in there and you'll get 3. Both of them the same. You're good to go. Are you okay with that? So you can do it non-graphically as well. So more than, make a note of that because that's how we continue from next day. Right? If you approach from the right, you use the function as more than. If you approach from the left, you use the function as less than. If you approach from the right, right? If you're approaching from the right, use the function where it's more than. If you're approaching from the left, use the function where it's less than. All right. So that's the intro into limits today. Homework, we read out the rest of the handout. Well, up until limits. Right? Take a look at it. You have some rules to learn. You have some rules to learn, then you have some simplifying. Then you have some more simplifying. Right? Then we will do out some past papers. Okay? All right, online. That's it for today. We'll continue next week, Wednesday, on the same thing. Although let me probably come in face to face, or we just keep it online, right? I'll ask you Wednesday or Tuesday night or something. All right, online. You all can log out. Bye. Bye. I'll see you all next week, right?
Bye, sir.